So topic 8.4 is about the identification of the ions, and in this part you have to learn the observations, and using the observations you should be able to identify the ion. Exam point of view, the question can come in both ways. Sometimes they give you the observation and you have to identify the ion, whereas sometimes we have to write the observation for the specific ion. So first we'll quickly go through this table, as this is a first session, so you don't most of you did not memorize these tests, but you should memorize as and continuously. It's not like you just memorize once, otherwise you will forget this. So you should revise again and again, like weekly revise this table, so it will help you to keep these tests and the results. So identification of the ions, if we want to identify the ions, how we can identify the ions? The first one is test for the positive ions. Positive ions are known as cation. For example, if I want to test an aluminum ion, so what we can do, there are two ways we can test the positive ions. One is by adding a sodium hydroxide, that is one way. So if we add sodium hydroxide and a salt contain aluminum ion, so what will be the result if you add few drops or 5 drops of sodium hydroxide or small quantity? You will observe a white PPT, white precipitate. What is the meaning of precipitate? Like you have a salt solution and you add sodium hydroxide or aqueous sodium hydroxide. So when you mix two solutions with each other, mixing the two solution, as a result, what you observe, you'll observe a solid is formed. This solid is known as PPT. So when you mix, you have a salt solution. Example, this salt contains aluminum ion. So this table is all about memorization. You understand the fact, but you have to memorize. Like example, we have a salt which contains aluminum ion. The term PPT means when we mix two solutions and a solid is formed, we call that as PPT. Example, this is an aluminum salt. What is the meaning of solution? So aluminum salt solution, this is colorless. In another test tube, what we have sodium hydroxide, NaOH. That is sodium hydroxide or NaOH. So both are solutions. Sodium hydroxide is a solution and aluminum is also a solution. But when we mix them together, when we add a small quantity of 5 drops of sodium hydroxide to this aluminum, what we will observe or what we will see a solid is formed. Then in the solution, the solids start to form. This solid which start to form, that solid is known as PPT, or we can also say precipitate. So if we have aluminum salt and we add drops of sodium hydroxide, like 5 drops, so what is the observation? We'll see that there are white precipitate or white colored solid is formed. The term precipitate means when you mix two solutions and a solid is formed, that is known as PPT or precipitate. When we add excess means like more than enough. If we add too much, initially we were adding 5 drops, but now we add too much. So when we add too much, what we'll observe? We'll observe the precipitate dissolve and it will form a colorless solution. So this PPT, originally it was there, but now what happened? It disappeared. So this precipitate will dissolve and it will form a colorless solution. So this gives an idea. What idea it gives? It gives an idea, maybe this solution contains aluminum ion. Is it clear, the first part? That when we add but you have to learn, actually there is no way, you have to memorize the color of the precipitate. If aluminum is there, it will be a white precipitate and which will dissolve to form a colorless solution. Same thing happen for lead salts as well. Like we have a container, we have a test tube which is having a lead salt. So lead salt solution is there. So originally this is colorless. Then what we do, we add drops of sodium hydroxide. A small quantity of sodium hydroxide is added, NaOH. So when we mix these two solutions, what we'll see a white PPT. What is the meaning of white PPT? Means when we mix two solution and a solid is formed, we call that solid as PPT. So as a result of this mixing, PPT will form, a white precipitate will form. But when we add excess means like too much, more than enough. So when we add too much sodium hydroxide, first we add 5 drops, but now we add too much. So the moment we add too much sodium hydroxide, what we'll observe for lead as well, we'll observe that the precipitate will dissolve. So the precipitate dissolve and it will form a colorless solution. And same thing happened for zinc salt as well. So the observation for lead, for aluminium and for zinc is same. So example, we have a zinc salt. And what we did, we add sodium hydroxide, NaOH. So when we add sodium hydroxide first, what we'll observe white PPT or white solid or white precipitate will form here. But when we add excess, the term excess means more than enough, like too much. So when we add an excess, what we will observe, we'll observe the precipitate dissolves and it will form a colorless solution. Is it clear till this point? The three observations. One is with the lead, first adding 5 drops and then we are adding in excess. Like excess, the term excess means more than enough. If we have a calcium salt solution, so example, we have calcium salt solution in a test tube. Salt solution, so it will be colorless for group 1, 2, 3. Now what we did, we are adding sodium hydroxide. So first we add 5 drops. The moment we add sodium hydroxide, what we'll observe white PPT. I am drawing black here just to represent, but in practical, it will be white PPT. But when we add excess means more than enough or too much sodium hydroxide. So as a result of adding excess of sodium hydroxide, this precipitate will not dissolve. So we will see the solid will remain there and the precipitate does not dissolve. Is it clear? The first four, aluminium, lead, zinc, and calcium. So you have to learn both things. You have to learn the observation with 5 drops and you have to learn the observation in excess. In exam, they can give you both ways, like they can give you a salt and they can ask adding a sodium hydroxide 5 drops in excess, what will be the observation? Or it can be other way around. They can provide you the observation, they can mention a white precipitate is formed which dissolve in excess, what could be the positive ion? So in that case, you can mention it can be a lead, aluminium, or zinc. But if there is a white precipitate which does not dissolve in excess, like which does not dissolve in excess of sodium hydroxide, so this confirms the presence of calcium. Then about the copper, so normally like copper solutions are colored solution and common color for copper is blue. So example, we have a copper salt here solution, and what we are doing, we are adding sodium hydroxide. So in a test tube we have NaOH or sodium hydroxide. When we add the sodium hydroxide, Whenever you have a copper salt, what you will observe? You will observe a blue PPT. So this precipitate, the solid which will form, that will be blue in color. And when we add excess, the term excess means more than enough, adding too much. So the moment you add excess, the precipitate does not dissolve or precipitate remain insoluble. So the solid will not disappear, it will remain as it is. So it means you have a copper ion. Then iron can be iron plus 2 or iron plus 3. So if it is iron plus 2, you have a iron salt solution in the beginning. So this is a iron salt solution and it means iron 2 salt solution, like it contain iron 2 ion. Now what we are doing, we are adding excess, like first we are adding drops of sodium hydroxide, NaOH. The moment we add drops of sodium hydroxide, we'll observe dirty green precipitate. So it will form a dirty green precipitate. And then when we add an excess, excess means like more than enough, like too much. So what we'll observe when we are adding an excess with this iron, the precipitate does not dissolve. So will the precipitate remain as it is, it won't dissolve. Same way, if we have iron 3 ion, so solution with iron 3 ion, like this is a salt solution, but this time it is iron 3, and we are adding sodium hydroxide. So you can see this is the same test. We are adding for each positive ion, we are adding sodium hydroxide, and as a result, we have to just memorize like what could be the observation. So sodium hydroxide is added. What is the observation when iron 3 is there to a salt which is like a salt solution contain iron 3 ion, and we are adding sodium hydroxide. So we'll observe red brown PPT. So this precipitate or red brown precipitate will form. And when we add an excess, the precipitate does not dissolve. So precipitate remain as it is. If we have a chromium ion, so we'll add sodium hydroxide, it will give a green color precipitate, and the precipitate dissolve to form a green solution. So first what happened? If we have this salt of a chromium, so we are adding sodium hydroxide. When we add sodium hydroxide, this test tube, first we'll observe a green precipitate is formed. So this will form a green PPT. But when we add excess, excess means more than enough, too much is added. So when the moment we add an excess, what we'll observe, the precipitate will dissolve, and as a result, the solution will turn green. So this is an observation for chromium. So copper 2, iron 3, chromium. And then for ammonium ion, as we know, this is also whenever we have an alkali, ammonium ions, if there's an ammonium salt, it will give out ammonia gas. So what is the test for ammonium ion? The same test is there, but only extra thing what is there is we are heating the mixture. So there's ammonium ion, NH4 ion is there. Okay. And what we did first, we are adding sodium hydroxide, NaOH. When we add sodium hydroxide, we don't observe anything. Now what we do, we start to heat it. The moment we start to heat, it gives a pungent gas is there, a gas is released, and that gas is having an irritating smell or a pungent smell. So we can identify that ammonium ion is present. And this gas, what it will do, it will turn red litmus paper blue. Like originally, if we were having a red litmus paper, as a result of this gas, emission of this gas, it will turn to blue. So these are the tests for the positive ions. We are adding sodium hydroxide, 5 drops, and then we are adding an excess. Is it clear till this point? Anyone having a doubt or a question till this point? The second way to identify the positive ion is by testing with aqueous ammonia, so or ammonia solution or ammonium hydroxide. So aqueous ammonia, ammonium hydroxide, ammonia solution, all are the same. Concept is the same. So what we do to test this ion, now example aluminium, we want to test aluminium. Now instead of adding sodium hydroxide, we can also add aqueous ammonia. So we take ammonia solution, sorry, the salt solution, like example, this is the aluminum salt solution. And to this aluminum salt solution, what we are doing, we are adding sodium hydroxide, NaOH, aqueous ammonia, not sodium hydroxide, aqueous ammonia or ammonium hydroxide. First, we'll add 5 drops. So when we add 5 drops, we'll observe white PPT. Because I cannot show white PPT here, so that's why I'm using a black color just to represent white PPT. And when we add excess, like we add more than enough, so what will happen? The precipitate does not dissolve. So this time, when excess of aqueous ammonia is added or ammonia solution, we don't observe that the precipitate dissolve. Previously, when we were adding sodium hydroxide, it was dissolving, but now it does not dissolve. The reason why I use a different color here, you can see I marked with a red. So this to show indication between the two tables, like what is the difference. When it was sodium hydroxide, it was giving a white precipitate and the precipitate dissolve. But with aqueous ammonia, it was white precipitate and precipitate does not dissolve. Same thing. So just why it is written in red here, just to make you understand that these are the differences between the two tables. When sodium hydroxide is added to a lead salt, it will be white precipitate, but precipitate does not dissolve. In the previous one, with lead, the precipitate dissolve, but here the precipitate does not dissolve. When we add aqueous ammonia, 5 drops to a zinc salt, white precipitate dissolve. It is written in the same color. It means that adding sodium hydroxide or adding aqueous ammonia is the same result. With calcium, when we add sodium hydroxide, it was white precipitate, does not dissolve. But with aqueous ammonia, there is no visible change or no reaction. With copper, when we add aqueous ammonia, it will be a blue PPT, which dissolve in excess to give a deep blue or royal blue or inky blue solution. With iron 2, dirty green precipitate does not dissolve. Iron 3, reddish brown does not dissolve. And chromium is green precipitate, dissolve to form a green solution. So the only difference is between the two tables is what I mentioned here in a red color. These are the differences. Now there's a video also related to these ions. When you will see the video, you can understand much better. So just a minute, I'll share with you that test for the ions. So test for the cation and anions, like we can identify the positive and the negative ions using this. Like we have different types of salts here. The first part, it's about the flame test that we'll discuss later. So example, if you want to test the positive ions, as these are initially given for anions, but we want to test the positive ions here. A test for the positive ions. Example, we have different salt solution. When white colored salts are there, what it shows? It shows that either group 1, group 2, or group 3 compounds are there, like the group 1 salts, group 2, or group 3, when the salts are white in color. But you can see some of the salts were colored. What it shows? It shows that transition elements are there, such as like iron, copper, chromium. These ions are there. These are the safety precautions related to a lab, as sodium hydroxide and aqueous ammonia. So first we have a salt solution, and to salt solution we add sodium hydroxide or aqueous ammonia. Like first we are making this salt solution, and then to salt solution we will add sodium hydroxide. This is the first, the salt solutions are there. You can see the salt solutions are colorless. If it is a transition element salt, then it will be a color. First, using 5 drops of sodium hydroxide, so you can clearly see then initially it was a colorless. Like initially there was no color for the solution here. But the moment we add 5 drops of sodium hydroxide, this is a salt solution. But to this salt solution, when we add 5 drops of sodium hydroxide, what we'll observe or what we'll see, you can see this white color solid is formed, and what we call this solid, we call that as a white PPT. So when we see white precipitate here, this gives an idea, that it might be an aluminum ion, it might be a zinc ion, or a lead ion. When we add an axis, like more than enough, so you can see the solution turned clear. So if the solution turned clear, this confirms that it might be aluminum or lead. But in the question, in the video, they already mentioned it is an aluminum ion. Same thing to a salt solution, we are adding aqueous ammonia. So again, you'll see white PPT here, this solid, this is called a precipitate. So when we add ammonia or aqueous ammonia to a salt solution, as a result, it will give white PPT. When we add excess, like more than enough, so what will happen? The first part, when we add sodium hydroxide, it form white PPT and dissolve to form a colorless solution. But the second part, it was white PPT, does not dissolve in excess of aqueous ammonia, and it confirm an idea that it contain aluminum ion. Is it clear till this point about the aluminum? That how we confirm the presence of aluminum? But this will be same, will result will be there with lead as well, because with the lead it will also give white precipitate which dissolve in sodium hydroxide, but in excess it does not dissolve. Is it clear this part? Anyone having a doubt or a question till this point? Then example, if we want to test, like here we tested aluminum. The second one, when we add, this is for aluminum. Now second one, what happened? When we add sodium hydroxide, it give white PPT, and it does not dissolve in excess. So it gives an idea it is a calcium, because calcium does not dissolve in excess. And with aqueous ammonia, there is no visible change. So as there is no visible change in aqueous ammonia, so this confirms the presence of calcium ion. So on the left hand side, you can see this was when we add sodium hydroxide. On the right hand side we add aqueous ammonia. So with sodium hydroxide, if it is a calcium salt, it will give a white PPT, but in excess the precipitate does not dissolve. Whereas aqueous ammonia, it does not even react, so there is no visible change or no reaction. So you can mention any of it. These are some, like in this video you don't find all of the ions result. It's just, this video is just to make you understand the concept. So here, first thing, as you can see, the solution is a colored. So it gives you an idea there should be a transition element or an element does not belong to group 1, 2 or 3. When we add sodium hydroxide, you will observe a dirty green precipitate. Here you can see an aqueous ammonia as well. The same result, dirty green precipitate. So if you are observing the dirty green precipitate in both cases, so what it confirm? It confirm an idea that iron 2 is present. If we have aqueous sodium hydroxide is added to a salt solution, we observe dirty, this red brown precipitate. So red brown precipitate is for iron 3. And same thing when we repeat this with aqueous ammonia, we are observing the same result of red brown precipitate. So both ways we are observing the red brown PPT. So if red brown PPT is there, what we can say? We can say that this salt contain iron 3 ion. Then we can also like test for aqueous cations, another cations we can also test. So first what we'll do in the same manner. First we'll add sodium hydroxide and then we'll add aqueous ammonia, but not in the same solution. We add to a different one. Some of the salts are colored, means there is a transition element, and some of the salts are white. It means these are group 1, 2 or 3 salts. So first we'll make a salt solution, and to a salt solution we will add sodium hydroxide. Like example here, we want to check chromium, copper, zinc and ammonium. So how we can test? Chromium, copper, zinc or aluminum, chromium is there, copper is there, zinc and ammonium. So this is a colored solution. Originally the solution is colored, so this confirms an idea that there should be a transition element. But this salt solution is a clear solution, so it means there is no transition element, a non-transition element. So first we take a salt solution into test tube, like we divide into two test tube. One is to add sodium hydroxide, another one is to add aqueous ammonia. So using a dropper, first we add drops of sodium hydroxide. When we add drops of sodium hydroxide, so we'll observe a green PPT, the green precipitate. And we continue adding this sodium hydroxide. So continuously we are adding sodium hydroxide, so you can clearly see the solution, the precipitate dissolved to form a green solution. Then the second one, we are adding aqueous ammonia to a chromium salt. So it is forming a green precipitate. So the first one, precipitate dissolve to form a green solution. The second one, the precipitate remain. If we are adding sodium hydroxide, we observe blue PPT, blue solid. So this gives an idea that the copper ion is present. And when we add an axis, the precipitate does not dissolve, the precipitate remain. But if we add aqueous ammonia, what we'll observe, it will form a blue PPT. And in axis, when we add too much, then we'll observe precipitate dissolve to form a royal blue or inky blue solution. Like you can see, like a blue ink, it will form a solution. As you can see now, this inky blue solution is formed. So first one, blue precipitate. The second one is an inky blue solution. Then we add sodium hydroxide. We observe white PPT. And then we add an axis, like more than enough. What we'll observe the precipitate dissolve to form a colorless solution. As we are mixing sodium hydroxide with a zinc salt. So originally it was white PPT, but then later the precipitate start to dissolve and it will form a clear solution. Then we'll add aqueous ammonia to the zinc salt, and what we'll observe a white PPT with aqueous ammonia, and then with few drops of ammonia, aqueous ammonia, and later when we add an access, what we'll observe the precipitate dissolve here, and again it form a clear solution. So both cases the precipitate dissolve for zinc. And with aqueous ammonia, like ammonium ion, as I mentioned, we'll add sodium hydroxide. We'll add sodium hydroxide and heat this. What we'll observe when we place a blue litmus, the blue litmus turned red. So this confirms an idea, or this gives an idea that this salt contain ammonium ion. So these are the tests for the positive and negative, positive ions, first part. Is it clear? So as I mentioned, all the observation in the video, that the positive ions adding sodium hydroxide and aqueous ammonia. Then you have, these are all like summaries here shown regarding that. And then you have to learn the flame test. Flame test means like using the color of the flame, we can also identify what kind of metal is present. If it is lithium, it will be crimson red. Sodium, it will be yellow. Potassium, it will be lilac. And with the copper, it will be green. So how we carry out a flame test, that also I will use a video to explain. So the flame test, we'll take a nichrome wire dipped in HCl, take a sample of the salt, and we'll place above the flame. So when we place above the flame color changes. As we know, like different salts will give you a different result. So if we take like sodium, so the flame color will change to yellow. So with sodium, it will give a yellow color flame. When sodium salt burn, they are responsible for that yellow color. Same thing, if potassium is there, it will be lilac. As you can see, the color of the flame, it is lilac. This is a nichrome wire, and we have a sample of salt on this nichrome wire. If it is lithium ion, then it will be crimson red. And if it is a copper ion or calcium, they took calcium as well. So that is also brick red for calcium. But calcium is not part, you don't have to learn here. You have to learn only 4 of them. Barium, again, it's apple green, but again, you don't have to learn this. This is just like having more examples so you have understand the concept well. And if it is a copper 2 ion is there, so what we'll observe a green flame. As you can see, the green color. That's due to the copper salts. So when you observe the firework, when the firecracker explode, so it give a different color. Here lead is there. So what is the reason why the firecracker is showing a different color? Is because it consists of different metals, and different metals, they emit out different energy. As a result, it will give a different pattern of the colors. Is it clear, the concept? Anyone having a doubt or a question till this point? So this was about the test for positive ion and the flame test. The next session we'll continue this and discuss the test for the negative ions.